Hello, grade 7. Our lesson today is actually lesson 4 from chapter 4, graphing a function rule. Now, in a graphing function rule, you know that we need x coordinate, xy coordinates, or the coordinate plane, because in which if you want to graph, it means that you want to draw, you want points. And actually these points, every one point consists of the x coordinate and the y coordinates. Now, to find the values of x's and y's, okay, I should remind you that x actually is the independent variable in which you can choose points, or you can choose values as you want, and I may call it the input values or the domain. Okay, more than one value of x, I call it the domain. And then I have the y values, which actually y is a variable that is dependent. It means that is affected by, or changing as x changing. It's actually a function or a rule of x, a function rule of x. Okay, and I can call it the output. Okay, and I can call or name more than one values of y, the range. Now then the function notation, which is fLx and which is y2. It's the function that we will write it in the lesson after this lesson. But here, just let's say, or graph a function. Okay, now if you want to graph a function, first you want the function itself, you want to graph it, and then you have to set table for graphing functions. You need table. Now table, it means you need more values of x and more values of y. Now, as I said, x, it's an independent variable, as you can see here, so you can choose x. Okay, although sometimes we have limits, but for your class, we can say that all of the real numbers are actually, we can choose them as values of x, since it's an independent variable. As we said that more than one value of x together, I call them the domain. Now, then I have to find y. Why I can find it from the function rule itself, which is this, since y actually is the dependent variable, so it needs you have to substitute x, okay, to get or to find out y. So in every time here, for example, for the first point, you would choose x0 for x, so you will substitute x in y function, okay, sorry, or in the in y, which is actually it explain, or it's y is actually a function of x. Okay, it's a function of x, so it means that it depends on x. There is a relationship between y and x, and it's explained by the function rule. So if you want to find y, you have to substitute x in y or in the function rule. Here, when you substitute it, you find out half times 0, it's 0, plus 3 is 3. Now this point here, it's actually this ordered pair, which is a coordinate of x and the coordinate of y. It's the point I will graph it on the xy coordinates. Okay, I will graph this point in the xy coordinates. How to get more points? Because actually one point is not enough. Even for a line, for a linear function, you need 2 points at least. So 1 point, it's not enough at all. You need more than 1 point. So you have to, to set x as you want, then substitute it, then find out the value of y, then set a point or put a point, and etc. until you finish your table here, and you can just graph it. You can use the points, you just find them, and then represent them or locate them in the xy axis. Now here, if you connect between these points, you can see a line. The line represents all x and y values that will make the equation true, and you can see that the line, if you see a line in the coordinate plane, you will say that I have a linear function. So this is a linear function. Since the graph of the linear function, it's a line, and this is a line, so we can say about it, it's linear function. Now, if we take another example, it's actually, problem from life, yani world life problems, or real world problems. And we choose the same, we choose the values of x, and then we substitute x and get the values of y, and then graph it, okay? We will get the same thing, we will get a line, okay, in which it can be represented as it represents a function rule. And I want you to notice this is the linear function, let's say the formula or the standard form of the linear function. It has, the independent variable multiplied by, a coefficient or a number, and it's added or subtracted, or or it could just be only the variable itself multiplied by a number, and or added or subtracted to a constant. Okay, now here, if you want to graph this function, since it has the same formula or the standard form as I told you, x is multiplied by 1 and then it's added to 2. So actually this is linear function. You can notice in linear function, the maximum degree, or let's say the maximum exponent, the maximum power is 1. Okay? This is why we call it linear function. Okay, so the maximum power here, it must be 1. It cannot be 2, or it's just 1, the maximum degree or power. Here you can see increasing function. How is that? As you are going from left to right, okay, you can see that the values are going or increase. Look here, for example, when it was 0, it's almost 0. When it's 2, even y increase, it becomes 1. When x is 3, y 1.5. So as you can see, when x increase, y increase. So this is an increasing function. While if you move from left to right in this graph here, you will notice that when x increase, y decrease. Look here, when x was 1, y was 1, as you can see here. But when x becomes 2, y actually 0. So as x increase to the right, y decrease. So I call it decreasing function. Okay, now Miss, actually this is the function, the graph of the absolute value function, دينا ماما مشان الله شوي بس، ماما بدي أكمل هالفيديو، أخذيها بس دقيقتين، إجت قطعتني من نص الفيديو، مش رح أعيده. يلا روحي سكري الباب ماما. Here looking at this, the function, the graph of the absolute value function, so this is the absolute value symbol, okay? And this is how the absolute value function is written. Now the graph of it is actually, it looks like V shape, as you can see here, okay? Now, and we can say here, it looks that its sign in front of the absolute value is positive, and sign in front of the absolute value is negative. Why? Because actually you can find out that the V shape is looking down, while here the V shape is looking up. Now, I just want you to know how the shapes of the other graphs will be, graphs, but not other functions, not the linear function. No need to, I don't want you to study them or to know their properties in details. I just want you to know that if the shape looks like V, you will know it's actually absolute value function. If the shape looks like U shape, looking upward or downward, it's actually, I call it quadratic function. The quadratic function, it has, this is the standard form for it. Okay, this is actually, it's not exactly the standard form, but we can say that the maximum degree of the quadratic function is 2. It's a quadratic, okay? So the maximum degree, the exponent, it's not less, it's just 2, okay? Yes, here you can see that since it's the U shape is looking upward, or looking up, so it's the coefficient of x squared, which is here, 1 here is positive, and here the coefficient of x squared. The coefficient means the constant or number that is multiplied by x squared. Here it's negative. But as I said, Miss, I don't want you to learn in details about absolute value graph and the quadratic function graph. No, I just want you to know their graphs in general. Now let's go to the book and start solving problems and discuss together if you have any questions.